All right, talking about sampling. If you took a sample of everything in the population, what is that called? Well, this, think back to your government classes. When you ask everybody, that's called a census. Some ways to make sampling better. Obviously, randomness is the big one, and to involve some kind of randomness, and large. The more people you ask, or the more subjects or experimental units, the better. A cluster sample. In a cluster sample, I'm going to just make some kind of short notes here. We use randomness to pick a group. Maybe I should say a whole group. So this was my, if you said, well, I want to do a sample of White Bear Lake Area High School South Campus. If I took every teacher's name, put it in a hat, mixed it up, pulled a teacher's name out, and I pulled out Danielson, I would just ask everyone in my classroom. And that would be it. I involved randomness, but the randomness picked a group. Okay, so that's a cluster sample. A simple random sample. We use randomness, and every individual has an equal chance. I'll use the symbol equal chance to be picked. And I'm going to run out of room here, but if you'll remember, actually, let me write it here. All groupings are possible. And this is, we talked about on the previous problem or previous page with our idea of, why is stratified sometimes better? Because it's possible in that example that if we just generated 1,000 phone numbers, we could get California and New York. Those are the most populous places. Maybe, Illinois. Maybe you only have 3 states that are even part of it. All groups are possible. It is possible in a simple random sample to have, every state or one state have all 1,000. But the bigger thing in a simple random sample is that every individual has an equal chance to be picked. Okay, systematic sample. We've talked about a number of times, and I'm going to just kind of do this. You have a system. Okay, you have a system for picking. This is where you say, you know what, I'm going to roll a dice. It comes up 4. All right, I'm going to ask every 4th person. So maybe you involve randomness, and maybe you don't, but you have a system for picking your sample. Okay, that's a systematic. A stratified random sample is you break the large group into smaller subgroups called strata. And then you do a simple random sample within each group. Okay, so like our example for states that you said, well, I really want each state represented. Then we break them into strata. The strata would be the states, and we pick 20 people from each state. Okay, and you know what? You could even make it proportional. You could do say, well, California has more people, so instead of picking 20 from California, I'm going to pick 50 from California and only 5 from Wyoming or something. But you break into these kind of like characteristic groups first, so that way you ensure that every group has some representation. Okay, a convenience sample. You ask those easiest to reach. Sorry, I'm getting a little sloppy here. And in a voluntary response sample, the participants, they pick themselves. Right? You go online and fill something out. Or, you volunteer yourself to be part of the sample. Okay, inference is one of the last things we talked about in this unit. and this idea of random sampling and random assignment and what they kind of allow us to talk about. Random sampling, this is where we have a group and we randomly pick the people to ask a question or to be part of our study or to be part of our experiment. Random sampling, the way we pick our sample, if we use random sampling, this allows us to generalize to the population. Okay? Because we hope through random sampling that we have an unbiased group and that they actually are representative of the entire population. So what does random assignment allow us to do? Random assignment, remember, is where we have our group and we use randomness to decide who gets the treatment, who gets the placebo, or who's part of the control group. This allows us to make cause and effect statements. Okay. And finally, few closing questions on the methods of sampling. We've talked about these a number of times. How can you use a random digit table? You assign the number, right? Assign numbers. You pick a line to read, and you go until you have, distinct or unique, however many you want, distinct, different, whatever, however you want to put it, numbers. And of course, in the random digit table, you may have extras, right? If you only have 25 people, certainly the random digit table, you maybe assign 0, 0 to 24. Anything over 25, you throw out and just move on. The calculator, the only difference, of course, you're still going to assign the numbers. You don't have to pick a line, but you're still going to then, you're going to use rand int. 1 comma blank, and then comma however many you want. Put that as n. And you still have to go until you get that many distinct numbers. Slips of paper. How we do that one? The kind of key things: identical slips of paper, in a hat. Mix it. Pick them out. Don't put them back in. We call that, don't replace them. Okay. So, we have these methods. In the AP exam, we typically use the slips of paper idea, but randint works as well, as long as you're clear that we're going to go until we have that many distinct values. Because, of course, when you use randint, you're picking 10, it's possible that 2 may come out the same. So you don't have enough participants. So you've got to mention that distinct numbers. Finally, I want to talk about experiment design. So what is a block design? So I like to think about this actually with kind of a picture. I usually start to think about like this. I say, all right, we've got a large group. Okay, the large group. And we have some defining characteristic that causes us to split them into a subgroup. So I'm going to put defining characteristic, DC. So this could be gender or age or size, or it could be so many, exercise regimen, whatever. But we break them into some defining characteristics into subgroups. Okay? So subgroup. And at that point, we experiment inside the subgroup. So at this point now we use random assignment. So for example, if you want to test some new blood pressure medication, you say, it might affect different genders differently, you'd split it. You'd say, okay, our defining characteristic is gender. So we're going to block by gender. Put the males in one group, females in the other, and experiment on them separately. This is the block design. The difference between this and stratified random sampling, a stratified random sample is a way of sampling that ensures that every group has been heard from. That's a sampling method. This is a way we design an experiment. Okay, so that's the difference. A matched pair design is one where we pair similar things for comparison. Okay, this, I know I've talked about the the plots of land, but imagine you wanted to test different metals or something like that, like pipe, and you said, well, I want to test how they're going to react, these different metals, in cold environments and warm environments. I'm going to put them in the oven. I'm going to put them in the refrigerator, and I'm going to see what the difference in their expansion or something is. Well, you aren't going to compare copper to steel. You're going to compare copper to copper. You're going to take a piece of this copper, you're going to put it in one in the oven and one in the fridge and compare them to each other and see what the difference is. And then you're going to do the same thing with steel or iron or aluminum. You're not going to cross compare. So a lot of times with matched pair, I like to think of this idea of a difference. That's really what we're comparing. What's the difference between the things we're comparing? If it is important that things be together and compared and their difference noted, it's typically a matched pair. Oftentimes with people, this is done as a before and after. Because, of course, for living things, there's nothing more similar to you than yourself. And finally, those 4 things to remember. Remember that we are setting up an experiment to do a comparison. Okay, we want to do a comparison between 2 things. So we involve random assignment in this, because an experiment, the goal is to show cause and effect. Okay, random assignment. And then we have a control group. It's important to have a control that we can compare back to. And at the end, whatever the results are, we should be able to replicate the experiment to show that the results are consistent.